To Joyce's geometry class. This is part 3 of lesson 2 on truth tables. So in this lesson, we're going to use truth table to prove the De Morgan's law. So first, truth table can be used to show that the statements are equivalent or not. So let's look at the De Morgan's law first. So the De Morgan's law states that uh, P or the negation of P or Q is equivalent to, this means equivalent, to the negation of P and Q, negation of Q. So same thing over here. This is the second part of De Morgan's law. It states that the negation of P and Q is equivalent to the negation of P or negation of Q. So let's use that to show use the truth table below here to show that these two statements are equivalent. So I'm going to use the first truth table, going to show that this is equivalent, and the second table to show that this is equivalent. So we call the equivalence, two statements are equivalent if every row in a truth table is the same. The true value is the same. So let's do the first one first. So I already set it up here. On the left-hand side, I set up the first component. I say this is a statement. I'm going to find a true value for it. It's from here. And then I find a true value for the second part of this statement, and which is from here, and which is a copy directly down. I just add a little space to it. I want to know at the end whether these two parts have the same true value. Okay, so now let's set it up in standard form first. Again, in standard form, we said first component is true, true followed by false, false, which half then is true, half then is false, and Q is alternating true, false. Okay. Now let's look inside this part here, this part. Inside this part, we see that, again, recall from last time we said that we work it from inside out. We're going to fill out the thing that we can with each simple component inside the parenthesis. Then we look at the connectives inside the parenthesis. Then look at the connectives outside our parenthesis. So now let's look at the first one, P. P is just the same as this P, so I'm going to bring it over. I have true, true, false, false. I'm going to do the same thing for Q. I just bring it over. So true, false, false. And then I'm going to use these two columns I just finished, column 1, column 2, to find the true value for the connective OR here. And recall OR is true if at least one the component is true. So in the first row over here, we have both components are true. Therefore, this statement is true here. And in the second row, I have one of them is true, so the statement is true. In the third row, I have one of them is true, so the statement is true. In the last row, both components are false. Therefore, the statement is false. I'm going to label that my column 3. Now, last part, I need to look at the negation. The negation of the parenthesis, which is the true value of P or Q. Well, column 3 gives me the true value of P or Q, so I'm going to negate column 3. Okay, I'm negating column 3. In this case, this is part here. So I have, in this column, the first row I have true, negation of true is false, so I have false and false. And then I have also false and then true. I'm going to label that my column 4. I finished the true table for the left statement, for this statement. Now I'm going to look at the right statement. And the statement is not Q and not P. So here for this one, I can look at, this is the negation of P. Negation of P, I'm going to negate that one. So negation of true is false. Negation of true is false. Negation of false is true. False is true. So I'm going to label that my column 5. Now, the next one, I'm going to negate Q. Okay, very similar, in a similar way. So here, first row is true, so negation of true is false. So this is true. Oh, let me write a little better. True is false, so this should be false. True, false, true. And I'm going to label this my column 6. Now, to find the n here, to find the true value for it, I'm going to use column 5 and 6. Going to give me the value. So n is true if both components are true. So by looking at this true table here, the only row where both components are true is row 4. So this is true, where the rest of them will be false. So false, 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 and that is 7, the 7 column. Now look at column 4 and column 7. Those are gives the true value of each statement. So notice that they are equivalent. They're the same. That is 2 here. You have the same true value. I have 3 false followed by true, same. So therefore, I can make the conclusion that not negation of P or Q is equivalent to not P and not Q. Okay. I can do the same thing for the second one of De Morgan's law. So I'm going to do the same thing here. And I'm going to write it in standard form. So first half is true, second half is false for the first component. And the second component alternating true, false. Okay. And I'm going to work inside out. First look at the component, then look at the connective. So first P, I just bring the P over. So true, true, false, false, true, false, true, false. Label the column. So 1, 2. Okay. Once I've done my 1, 2, I can use the first and second column to look at the conjunction, the connectives inside the parenthesis. So again, we call that n is true if both components are true. So column 1 and column 2, where both components are true, is row 1. So row 1 is true. So I have true. And so the rest of them is false, false, false. And that will be column 3. Now, to finally fill out the last connective, this is the negation of the whole statement, P and Q will be column 3. So I'm going to negate column 3. In column 3, the first row is true, so negation must be false. Okay, so negation of false is true, so true, true, and that is column 4. Now, I'm going to do the same thing on the right-hand side here for the not P or not Q, or negation of P or negation of Q. So negation of P, I'm going to use the P column to do the negation right here. So P is true in the first row, so the negation must be false. So false, true, true, and negation of Q is in the same way. So false, true, false, true. I'm just going to label the column. Column 5, 6. The labeling just make it easier for discussion. So here, now let's look at the connective OR here. To do this connective OR, I'm going to use the column 5 and column 6 to figure it out. OR is true if at least one of the component is true. So the first one is false because both components are false. So this is false. This is true. Second row is true because one of the component is true. The third one is true because one of the component is true. The last one is true because both components are true. And that is my column 7. Now, notice that column 4 and column 7 have the same true value as well. So, therefore, I can make the conclusion that these two statements, negation of P and Q, is equivalent to not P or not Q. If we have any further question about truth tables and making truth tables, I suggest I look at our video 1 and 2, which is lesson part 1, part 2. See you next time.